Welcome to Ganita Samayaha, an interactive learning space. Children, as I proceed with my teaching, whenever I pose in questions, please answer them. This will help you in the learning process. Also, please don't forget to have the writing materials with you whenever you watch these videos. And after you watch, please subscribe, like, and share the video. Today we continue with triangles part 4. The link to other three parts are given in the description box below. So let us get started now. So let's get started with the assignment that was given to you in the last video. So the first question goes like this. Measures of some angles in the figure are given. Prove that AP by PB is equal to AQ by QC. We need to prove that AP by PB is equal to AQ by QC, which means that we need to prove that PQ is parallel to BC. Isn't it, children? So let's get started with the proof. What are we given? We are given angle APQ is equal to angle ABC. So looking at the figure, what can you say about this pair of angles? Angle APQ and angle ABC? Yes, they are corresponding angles. Angle APQ and angle ABC are corresponding angles. And these corresponding angles are equal as well. When what can happen to this line PQ and BC when it contains two angles which are corresponding and they are equal? Yes, they become parallel. That's all. So PQ is parallel to BC. If PQ is parallel to BC, we can apply our BPT and say that AP by PB is equal to AQ by QC. Is it clear, children? I hope all of you have got this right. Okay. Let us look into the next question that was given. The next question goes like this. In the given figure, LM is parallel to AB. Then the measurements of line segments AL, AC, BM and BC are given. You are asked to find the value of X. So you are given a triangle ABC in which LM is parallel to AB. The measurement of AC is given to be 2x and that of AL is given to be x minus 3. So also the measurement of BC is given to be 2x plus 3 and that of BM is given to be x minus 2. So if we have to apply BPT, then we need the measurement of CL and CM as well. Isn't it, children? So is it difficult for us to find these values? Not at all. So CL is 2x minus of x minus 3, which is x plus 3. So also CM is 2x plus 3 minus of x minus 2, which is x plus 5. So knowing all these measurements, we simply have to apply BPT, substitute. That's it, children. Okay. So let us get on with the solution. So from triangle ABC, we have AB parallel to LM. Hence we have CL by AL equal to CM by BM. Substitute all the values. X plus 3 over x minus 3 is equal to x plus 5 over x minus 2. Cross multiply and then simplify. Okay. On simplification, we get the value of x is equal to 9. Is it clear, children? Have you all got this answer? Very good. So let us proceed with today's lesson. So hitherto we have learned that given a triangle ABC and you have a line DE parallel to BC, DE divides the other two sides proportionally. If you have DE parallel to BC, it divides the other two proportionally. Meaning if DE is parallel to BC, AD by BD is equal to AE by EC. Now, is the reverse true? That means, suppose you have some line DE such that it divides two sides of the triangle proportionally. That means, you have got points D and E such that AD by BD is equal to AE by AC. Is this line parallel to the third line, third side? That means is DE parallel to BC? Okay, children. So let us establish that. If a line divides any two sides of a triangle in the same ratio, is a line parallel to the third side. So what are you given? You are given a triangle ABC in which DE is a line which divides the two sides in the same ratio. That means what? It divides AB and AC in the same ratio, which means AD by BD is equal to AE by EC. So let us write whatever we are given. You are given a triangle ABC in which DE divides AB and AC in the same ratio. Same ratio means what? AD by BD is equal to AE by AC. What are we asked to prove? We have to prove that DE is parallel to BC. Okay. Now, let us assume that DE is not parallel to BC, children. So, in that case, there must be some line through D which must be parallel to BC. Last year under postulates with respect to parallel lines, we have studied this. Given a line and a point outside it, through that point, there must be one and only one line that is parallel to the given line. So now we have a line BC and we have a point D outside it. So through D, there must be a line parallel to BC. Is it clear, children? Let DE not be that line. Let it be some other line DE dash. Is it clear, children? So, we have DE dash parallel to BC. Now, can we write the proportion with using our BPT? Yes. So, let us write down the proof now. So, what are we considering? Let DE not be parallel to BC. Instead, let DE dash be parallel to BC. As a result of which, let us apply BPT. We have AD by BD equal to AE dash by E dash C. AD by BD is equal to AE dash by E dash C. But what is AD by BD equal to? Yes, it is equal to AE by EC, which is given to us. Okay. So what can we conclude now, children? The left hand sides are equal means the right hand side must be equal. So we have AE dash by CE dash equal to AE by EC. Now let us look at the figure now. We have AE by EC equal to AE dash by E dash C. Okay. Now, is it possible for us to have 2 points that is dividing the same line segment in the same ratio? It is something like this, children. Suppose I have got a line AC and I have got a point P such that it is dividing this line in the ratio say 2:1. Okay. Now, is it possible for me to have another point here which can divide this AC in the same ratio 2:1, or some point say here that divides the same line segment AC in the ratio 2:1? No, it is not point. This point P is unique. There is one and only one point that divides a given line segment in a particular ratio. Is it clear, children? So that is what is happening here also. Okay. So this point E and E dash, there cannot be two different points. There must be one and only one point that divides this in the particular ratio. So what does this mean? It means that E and E dash are one and the same point. They are not different points. That means E and E dash coincide. Okay. So if E and E dash coincide, we assume that DE dash is parallel to BC, which means that DE is parallel to BC. Hence, if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Is it clear, children? So with this, we come to another important conclusion which states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay, and this is called as the converse of BPT. Converse means the reverse. If A is equal to B, the converse is B is equal to A. So we had that if a line is parallel to one side of the triangle, it divides the other two sides of the triangle in the same ratio. Now it is a reverse. If you have a line that divides two sides of a triangle in the same ratio, then that line must be parallel to the third side. Is it clear, children? Let us work out a few problems based on this concept. Okay, are you all ready? Good. Now, we have got a triangle PQR in which some of the parameters are given. We have to find out if NM is parallel to RQ. We have to find out if NM is parallel to RQ. Is it clear, children? So you are given the value of PR and NR. We are also given the value of PQ and PM. So we need to apply the basic proportionality theorem, BPT, which means we should know the value of NR and PN, PM and MQ. So given PR and NR, is it difficult for us to find PN, children? Not at all. It is 20 minus 8, which is 12. So also here we have got PQ as 25 and PM as 15. So what will be MQ? 25 minus 15, which is 10. Okay. Let us apply BPT and then substitute. Okay. So we will first consider PN by NR. Okay. If Pn by Nr is equal to Pm by Mq, then we can arrive at the conclusion that Nm is parallel to Rq. Isn't it? So, if Nm has to be parallel to Rq, then Pn by Nr must be equal to Pm by Mq. So, let us take the ratio Pn by Nr first. Pn by Nr is equal to 12 by 8, which is 3 by 2. Okay. Then let us find the ratio Pm by Mr, which is 15 by 10. That also comes to 3 by 2. So what can we conclude? Pn by Nr is equal to Pm by Mq, which means that Nm is parallel to Rq. Is it clear, children? Such problems just apply BPT but don't apply it together. Take only the left hand side first, find out its value. Take only the right hand side, find its value. If the two are equal, then say that they are equal and then conclude that they are parallel. In case the two ratios are not equal, we will say that this ratio is not equal, hence they are not parallel. Is it clear, children? Let us work out one more problem now. D and E are points on sides AB and AC. D and E are points on sides AB and AC respectively of triangle ABC. So you are given some measurements. You are given AB as 11.7 and BD as 5.2. So what will be AD? 6.5. So also you are given AC as 9.9 and AE as 4.4. So what will be EC? 5.5. So we are asked to prove if DE is parallel to BC. We will consider the ratio AD by BD first. So what is AD by BD? It is 5 by 4. 6.5 by 5.2, which simplifies to 5 by 4. 13 into 5 is 65. 13 into 4 is 52. Okay. We will then find out the ratio AE by EC, which is 4.4 by 5.5. And on simplification, we get 4 by 5. So what do we observe? AD by BD is not equal to AE by EC. Okay. So what do we conclude? We conclude that DE is not parallel to BC. That's all, children. Okay. So these are the problems that you will have with respect to converse of BPT, asking you to prove whether it is parallel or not parallel. Okay. Then we use this on some application problems as well. Let us see a few of them now. So you are given a figure in which DE is parallel to OQ and DF is parallel to OR. I've already told you that if you have got two conditions, then you will have two statements. Comparing those statements, you can arrive at the result. Okay. So we are given that DE is parallel to OQ. Let us consider that first. DE parallel to OQ. DE is parallel to OQ. So which is the triangle that we will be considering with OQ as one of its side? OQP. This is the triangle. So you should see only this triangle, children. OQP. Inside that DE is parallel to OQ. So once you see a triangle and a line parallel to it, immediately you will apply BPT. So according to BPT, what do we have? We have PE by EQ equal to PD by OD. Is it clear, children? PE by EQ is equal to PD by OD or DO. Okay, fine. Let us call this as statement 1. Now, we have got another condition. What is that? DF is parallel to OR. Look here. DF is parallel to OR. So, immediately you will have to take that triangle which contains OR as one of its side. Of course, you must have this line within it. Don't go for O or Q. No use. You should consider O or P because we are interested in having this DF parallel to OR as well. So this is a triangle we are going to consider. ORP. Okay. Inside that DF is parallel to OR. We can apply BPT and write the ratio again. Okay. So let us write that now. DF is parallel to OR, which implies that from triangle ORP, PF by FR is equal to PD by OD. Isn't it, children? PF by FR is equal to PD by OD. So let us call this as statement 2. So observing 1 and 2, what do you notice, children? Right hand side is the same, PD by DO, PD by DO, which means that the left hand side is equal. So we'll write that PE by EQ is equal to PF by FR. Now let us observe the figure. PE by EQ is equal to PF by FR. So which is the triangle that you should spot now? PQR. PE by EQ, top by bottom, is equal to PF by FR, top by bottom. So you should see only this triangle PQR now, children. Okay. So in this triangle we have PE by EQ equal to PF by FR. So what can you say about this line EF and QR? Parallel. Why? Converse of BPT. That's all, children. Okay. So this means that EF is parallel to QR. And that is what we are asked to prove. And we have established that very easily. So interesting, isn't it, children? We have got two conditions. We consider that and we get two statements. We compare them and then we get back to the figure, analyze it and then write it. That's all. If you are strong with BPT, any of these problems you can handle very easily, children. Okay. Let us see one more problem. Okay. What is the value of X that will make DE parallel to AB? So you are given all the values of these line segments, say AD, DC, CE and AB in terms of X. Okay. We have to prove if DE is parallel to AB. No, we have to find what is that value of X which will make DE parallel to AB. So if D is to be parallel to AB, we can apply BPT substitute. That's all. Nothing with this problem. So if D is parallel to AB, then we know that CD by AD is equal to CE by B. Substitute all the values in terms of X that you are given. Then simplification is first you cross multiply them. X plus 3 into 3, X plus 4 is equal to X into 8, X plus 9. Simplify it and then we get a quadratic equation here, 5x squared minus 4x minus 12 equal to 0. We know how to factorize this by splitting the middle term. The coefficient of x is minus 4. So you have to find two numbers such that their product is the product of the first and the last term, the coefficient. 5 into minus 12, minus 60 and the sum is minus 4. So which are those numbers? Minus 10 and 6. So we have 5x squared minus 10x plus 6 minus 12 equal to 0. This on rearranging and factorizing, we have x is equal to minus 6 by 5, which is a negative number, and we cannot have measurements in negative. So, it is neglected. We have x is equal to 2. Is it clear, children? So, we use this converse of BPT to work out such problems as well. Clear? Okay. So here we have got a case wherein ABCD is a trapezium with AB parallel to DC. So this is our trapezium, children. ABCD is a trapezium. We know what a trapezium is. It is a quadrilateral which has got one pair of opposite sides parallel. So here we have AB parallel to CD, AD and BC are the non-parallel sides. Okay. We are also given that E and F are points on the non-parallel sides AD and BC. So E and F are the points on this non-parallel side. Okay. Such that EF is parallel to AB. Is it clear, children? We are asked to prove that AE by ED is equal to BF by FC. Okay. So EF is parallel to AB, but AB in turn is parallel to CD, which means that all these lines are parallel to each other. Okay, children. Now AE by ED is equal to BF by FC. This we cannot directly establish because we need a triangle. Only when there is a triangle, the parts of one side will be proportional to the parts of other side. We don't have a triangle here. So what do? We make a triangle. How? By joining AC. When you join AC, you get a triangle, isn't it, children? So that will be our construction. So what is the construction? Join AC to intersect EF at P. Okay. Join AC, let AC intersect EF at P. Okay. Now, from this triangle ADC, we have EP parallel to DC. Isn't it? We have established that all these lines AB, EF and DC are parallel to each other. So, EP is a part of this EF. So, EP is parallel to DC. Can we use BPT here now? Yes, we can. So, we will apply that. Okay. So, proof. From triangle ADC, EP is parallel to DC. So, AE by ED is equal to AP by PC. Let us call this as equation 1. Okay. Now, we want BF by FC. So, which is the triangle we will consider now? BCA. Is it clear, children? There we have PF parallel to AB. Again, we can write the proportionality using BPT. So, from triangle ABC, we have PF parallel to AB, which means that BF by FC is equal to AP by PC. Let us call this as equation 2. So, what do we find from these two equations? Right hand side is the same. AP by PC. That means the left hand sides are equal, which means that AE by ED is equal to BF by FC, and that is what we want. So easy, isn't it, children? Yes. So comparing 1 and 2, we have AE by ED equal to BF by FC. Clear? Good. Now let us proceed further. We have to prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. What does this statement mean? Let us understand. We have got some triangle ABC and D is a midpoint of say AB. Okay. Through D, if I draw a line parallel to BC. Okay. DE is a line drawn through the midpoint of AB parallel to BC. We have to prove that this point E is the midpoint of AC. Okay. If D is a midpoint of AB, it means that AD is equal to BD. If E has to be the midpoint of AC, it means that AE must be equal to EC. So that is what we have to prove. What are we given? We are given a triangle ABC and a point D such that AD equal to BD and DE is parallel to BC. What have we to prove? E is the midpoint of AC, which means that we have to prove that AE is equal to EC. Is it clear, children? So let us write down what we know. That is what is given to us. You are given a triangle ABC in which D is the midpoint of AB. If D is the midpoint, we know that AD is equal to BD. Let that be equal to some quantity X. Okay, children? Let AD equal to BD be equal to some X. We are also given that D is parallel to BC. What are we asked to prove? We have to prove that E is a midpoint of AC, meaning that AE equal to EC. Clear? Now, proof. Let us apply BPT. From triangle ABC, DE is parallel to BC. Okay? Which means that AD by BD is equal to AE by EC. Okay, we know the measurements of AD and BD. We have supposed it to be X. So let us substitute AD as X and BD as X. So we have X by X is equal to AE by EC. On simplifying, this X and X will get cancelled. We are left out with 1, which means that AE by EC is equal to 1. Okay, and this means that AE equal to EC. If AE is equal to EC, it means that E is the midpoint of EC. That's all, children. Okay? Have you understood this? Good. Next, please don't take anything from memory. It's all there, given there in the problem itself. That's all. Once we see a triangle and we see a line parallel it, immediately we will apply BPT. We will look for the other conditions. We are given D is a midpoint, which means that AD and BD are equal. So let us suppose that to be some X. That's all. Then simplify it, you will get the answer. Nothing different. Is it clear, children? Let us work out one more problem. Okay. So we have to prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. The reverse now. You are given that D is the midpoint of AB. You are given E is the midpoint of AC. We have to prove that DE is parallel to BC. Is it clear, children? D is the midpoint of AB means what? AD is equal to BD. Let that be equal to some X. E is a midpoint of AC means what? AE equal to EC. Let that be equal to some Y. Apply BPT and let us see what happens. BPT or its converse. Let us see. So you are given a triangle ABC in which D is a midpoint of AB, which means that AD equal to DB equal to some X. You are also given that E is a midpoint of AC, which means that AE equal to EC is equal to some Y. Okay. So you are asked to prove that DE is parallel to BC. Okay. So let us consider AD by BD equal to X by X. Let us just substitute for AD as X and X. Okay. Since we have to prove that DE is parallel to BC, we have to establish that both these ratios are same. That is what we have to do, isn't it? So that's why we are finding the ratio of AD to BD and we will find the ratio of AE by EC also. Let us see if the two ratios are same. Now we have got that AD by BD is equal to 1. Let us call this as equation 1. Let us find out AE by EC. We have assumed that AE and EC are Y. Substitute. This also we have got 1. Let us call this as statement 2. Okay. What do we observe from 1 and 2? AD by BD is also 1. AE by EC is also 1. Which means that AD by BD is equal to AE by EC. Okay. So if AD by BD equal to AE by EC, what does it talk about D and BC? They are parallel towards each other according to converse of BPT. Is it clear, children? And that is what we need and we have established it. Okay. Proceeding further, we have got another problem which says that ABCD is a trapezium in which AB is parallel to DC and the diagonals AC and BD intersect at O. We have to show that AO by BO is equal to CO by DO. Okay, children. So let us first write down what we are given and what we need to prove, and we require a small integration into this. Okay, we need to rearrange this ratio, and let us see how we can do this. Given ABCD is a trapezium in which AB is parallel to CD, AC and BD intersect at O. Whatever you are given here in the statement, children, same thing we are writing in the mathematical form. ABCD is a trapezium, that is written as trapezium ABCD, in which AB is parallel to CD. Okay, its diagonals, we know what are the diagonals. AC and BD intersect at O. This is what you have written. What have we to prove? AO by BO is equal to CO by DO. This is what we need to prove. Okay. I told you we will do a small rearrangement. That means AO by BO. AO by BO. Instead of that, we will rearrange it and write it as AO by CO is equal to BO by DO. So we will aim at proving that AO by CO is equal to BO by DO, which means that AO by BO is equal to CO by DO. Simply because it is easier for us to prove this, isn't it, children? AO and CO are parts of one side of a triangle. Okay, whenever we see parts, we should take that complete triangle. Okay, we have AO by OC. When you see this triangle ADC, you have AO by OC. Okay, that is why we will do this rearrangement. We will try to prove that AO by CO is equal to BO by DO. Okay, if you want AO by OC, we can do that only if you have a line through O parallel to DC. Isn't it, children? So, let us draw a line through O parallel to DC, meeting AD at some point. Okay. So, this is the line that we are going to draw. This is our construction. So, through O, draw OP parallel to CD. Now, look at this triangle ADC with OP parallel to CD. Very easy to write the proportionality using BPT, isn't it, children? AO by OC is equal to AP by PD. Fine. So, let us write that. From triangle ADC, PO is parallel to CD. So, we have AP by PD equal to AO by OC. Clear? Fine. Is this sufficient? We are also interested in knowing about BO and OD, isn't it? So, through O, we have got OP parallel to AB as well. For that, we will consider this triangle BDA. Okay, children? If you consider this triangle BDA, we have the same PO parallel to AB now. Is it clear? So, we can write the proportionality that AP by PD is equal to BO by OD. AP, this part by this part. Okay. We start from the base up to this line and then go to the vertex. Again from the base to this line to the vertex. Okay. So, we have let us call this one AP by PD equal to AO by OC as equation 1. Now, from triangle ADB, we have PO parallel to AB and we can write that AP by PD is equal to BO by OD. Let us call this as equation 2. Now, we will compare 1 and 2. Left hand side is equal. So, the right hand side becomes equal. As simple as that, children. That's all. You should not get scared at all. All these, if you have got a good hold on BPT, happily you can go on handling it. I told you recognize a triangle and a line within that, apply BPT. That's all we have done. First we recognize this triangle ADC. We recognize that PO is parallel to CD and we wrote this ratio AO by OC equal to AP by PD. Now the same OP, it is going to be parallel to AB. So now which is this triangle? The other triangle ABD. Okay. Again apply this BPT. AP by PD is equal to BO by OC. We find that AP by BD is common, so the right hand side will be equal. So comparing 1 and 2, we have AO by OC is equal to BO by OD. Again, we rearrange this because we want it in the original format that is asked. So AO by BO is equal to CO by DO, which is what we want, and we have established. Clear, children? Hope you're all enjoying this. Good. Let us go and work out one last. In this problem, we have got the diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by CO equal to BO by DO. We have to show that ABCD is a trapezium, children. So we have got some quadrilateral ABCD such that its diagonals AC and BD intersect each other at the point O so that AO by OC equal to BO by OD. We have to prove that ABCD is a trapezium. To prove ABCD is a trapezium, we have to prove that one pair of opposite sides are parallel. So we will prove that AB is parallel to CD. Is it clear, children? So what are we given? We are given a quadrilateral ABCD such that AC and BD intersect at O so that AO by CO equal to BO by DO. What are we asked to prove? ABCD is a trapezium. That means we have to prove that AB is parallel to CD. Okay. Now, let us consider this triangle BDC. So we have got BO by OD, that part, isn't it, children? We have BO by OD. Okay. So when we have this BO by OD, we will consider this triangle BDC, which means that we should have a line through O parallel to CD. So let us draw a line OP parallel to CD. Okay. So we can apply BPT from this triangle BDC. So what is our construction? Construction is through O, draw OP parallel to CD. From triangle BDC, we have BO by OD equal to BP by PC. OP is parallel to DC, so we have BO by OD equal to BP by PC. Is it clear, children? But let us call this as statement 1. But we have that BO by OD equal to AO by C. It's already given to us. And we have established that BO by OD equal to BP by PC. So what does this indicate? This indicates that BP by PC is equal to AO by OC. The left hand sides are equal, so the right hand side must be equal. BP by PC must be equal to AO by OC. BP by PC is equal to AO by OC. Consider this triangle now, ABC. We have BP by PC equal to AO by OC. So what does this mean? Converse of BPT says that OP must be parallel to AB. Isn't it? But we have already constructed OP to be parallel to CD. Isn't it, children? So from triangle BDC, we have if BP by PC is equal to AO by OC, then OP must be parallel to AB. But OP is already parallel to CD by construction. So what does this mean? All the three are parallel to each other. That means AB is also parallel to CD. This says that ABCD is a trapezium. Okay, children. So we have proved this problem as well. Let us go to one last concept in this video. Okay. This is an extension of our BPT, children. This simply states that if a line intersects sides AB and AC of a triangle ABC at D and E respectively and is parallel to BC. That's all. We have got a triangle ABC in which DE is parallel to BC. We have to prove that AD by AB is equal to AE by AC. We know AD by BD equal to AE by EC. This is just an extension, a little of mathematical work. That's all, children. But this result is very important for us. Is it clear? So let us write down what we are given. What are we given? A triangle ABC in which DE is parallel to BC. Okay. Then what are we asked to prove? We are asked to prove that AD by AB equal to AE by AC. Okay. So let us prove that. Let us first consider DE is parallel to BC and apply our BPT. That's all. So we apply BPT. Consider AD by BD equal to AE by EC. Okay. This is according to our BPT. Fine. We will reverse this and write. I will tell you why later on. Okay. So this implies that BD by AD equal to EC by AE. We have simply interchanged the numerator and the denominator. We have taken the inverse, children. AD by BD is written as BD by AD and AE by EC is written as EC by AE. Fine. Okay. Now we are interested in having AB somewhere. Okay, children. So what is the relation between BD and AD? BD plus AD is AB, isn't it? So, if I want to have AB in the numerator, I have to add AD to it. How do we add AD? Suppose I add 1 to this ratio, then it becomes BD plus AD. So, also on the right hand side, if I add 1 to this ratio, I will have EC plus AE. Is it clear, children? So, we simply add 1 on both the sides. On simplification, we have BD plus AD, isn't it? Plus BD by AD plus 1 is nothing but BD plus AD by AD equal to EC plus AE by AE. But what is BD plus AD in the figure? AB. And what is EC plus AE in the figure? AC. So, we have AB by AD equal to AC by AE. But what do we want? We want AD by AB. So, take the reverse again. So, AD by AB equal to AE by AC. Why did we take the inverse here? That is because suppose we had added here, 1 here directly, then we would have got AD plus BD by BD we would have got. But what do we want? We want AD, isn't it, children? So, whatever we want in the numerator, I have seen that it is there in the denominator. That's what we do. Okay. We are simply taking the reverse because we want AD. We don't want BD. That is what is asked in the for us to prove. Okay. That is why we took the reverse, just added 1 and we got this result. So, this is an extension of our BPT. It is called as corollary. Okay. Anyway, if we don't use that word corollary, but we can use this result sometimes later. Is it clear, children? This is just an extension of BPT. BPT says that AD by BD equal to AE by EC. But here we have proved that AD by AB, the top over whole, is equal to top over whole on the other side, is equal to AE by AC. Is it clear, children? And the other one is also true. BD by AB, bottom over whole, is equal to EC by AC, bottom over whole. So with BPT it is top by bottom equal to top by bottom. Extension of BPT, which we call it as corollary, means top by whole is equal to top by whole, or bottom by whole is equal to bottom by whole. Okay, children. So this is another important conclusion that we come across, that AD by AB equal to AE by AC, which says that if a line intersects two sides of a triangle at two distinct points and is parallel to one side of the triangle, then the two corresponding sides of the two triangles are proportional. So this we call it as the corollary of BPT. Is it clear, children? Okay, let us proceed. So as usual, I have got some assignments for you, children. We have got about 5 problems. Please do all these on your own. I hope all of you have understood it. Please try it out. Let us discuss the same in the next video. So what have we learned today, children? we have learnt about the converse of BPT, and we have worked out some problems related to it, related to both BPT and its converse. Okay, very simple. Please understand it slowly. If you want, you can watch this video as many times as you want, but don't take anything from memory when we are doing it. Please understand the concept, analyze it. At each stage, I have guided you on how you will be analyzing it. Isn't it, children? So please use all those things and work out those problems, and we will meet in the next video. Thank you for watching. Please don't forget to subscribe, like, and share this video. And if you have any doubts, please put them in the comment box. I will get back to you as soon as possible. Thank you.